Okay, good morning, everybody. So I think there's two topics in today's lecture. So the first topic is these things called enumerated types, and then the second topic is going to be we're going to move into the second major part of the course. So to start with enumerated types, we're going to, if we just quickly look at this list of items here, and ask yourself the question, what do these things have in common? Right, so you got days of the week, months of the year, suits and a standard set of playing cards, and so on and so on and so on. So if you look at that list there, it might occur to you that each group, so the days of the week, for example, has a fixed number of items, and those items never change. And then you might argue about some of these as well, right? So planets in the solar system, that number seems to change every once in a while. Right? Canadian coins also seem to change every once in a while. Pennies no longer in circulation. Right? Canadian provinces and territories, they also change very occasionally. But most of these things seem to be constant groups of items. Right? So when you're in a situation where you need to represent a constant group of items, you can use this thing called an enumerated type. Most people just call these enums for short. Right? So an enum is just a type whose values represent a fixed set of constants. Right? So for the months, for the days of the week, you've got Saturday through Sunday, Sunday through Saturday, sorry. For the months, you've got January through December, and so on and so on and so forth. Another common feature of these types is that often these things have some sort of sorting order. Right? So many countries use the convention that Sunday is the first day of the week. Right? January is the first month of the year. The suits of a set of playing cards, those aren't necessarily in any sort of order, but the values are. Right? So many card games use the ordering 2, 3, and then the face cards. All right, so if you need to implement an enumerated type, there used to be the way you used to do this in Java, and the way you still do it in C, is you typically just make a bunch of constants whose type are int. Right? And so in Java, you might write something like public static final int Sunday and give that the value 0. Right? Public static final int Monday and give that the value 1, and so on and so on and so on. Right? Similarly, if you needed the months in the same program, you might do January equals 0, and so on and so on and so on. Right? In C, you actually have something called an enumerated type, so the keyword enum exists in C, but it really is just a thin wrapper around this sort of thing. Right, so your enumerated types in C, they're just plain old ints as well. Right, there's a big problem with doing this. So I guess the advantage is you now have a named constant that you can use in your program. However, that named constant is still an int. Right? And a month or a day of the week or something like that is not really an int. Right? It really is its own thing. So if you're using this technique of an int to represent some kind of type, right? Then it becomes, there is a complete lack of what's called type safety, right? So any method that takes in an int will accept a month or a year, for example, a month or a date or a day. So for example, in Eclipse, right? So here's my days of the week represented with an int. And here are my months of the year, again, represented as ints. Right? And there's a little method here that computes the number of days in a given month. Right? So that's a Java switch statement. If you don't know what a switch statement is, don't worry about it. It's basically a big if statement. Right? So if the month is January, March, May, July, August, or October, or December, that month has 31 days in it. Right? If the month is February, it has 28 days in it. We're ignoring leap years. Right? Otherwise, all the other months have 30 days in it. Right? So the problem with that method is it's taking in an int. So you can call that method with January, right? And you get the right answer. You get 31 days in January. But you can also pass in Tuesday. And so now you get the number of days in Tuesday, which doesn't make any sense, right? You can pass in the number 1,000 and ask how many days does 1,000 have, right? And if you run that program, it doesn't crash. It actually runs, right? So, oops, sorry. I've never seen that before. What just happened? Console. There we go. Right, so January has 31 days. Tuesday has 31. I guess I should put a space in here. Tuesday has 31 days. Oof, sorry, let me put in the space, this is hard to read. Yoink. And that was a cut and paste error, days and week. Okay. Oh, and now I have a plus, plus, there you go. Right, there we go. So apparently 1,000 has 30 days. If you use an enum though, so if you use Java's proper enumeration type, which looks like that, you'll see in a moment that you can even write methods that belong to your constants, and you can get the correct number of days, in this case, for a given, whoops, sorry, what is going on here? For a given year, right? Okay, so this lack of type safety is a big problem, right? There's no way to restrict a parameter to be only a day or a month, right? Any old int will do, so that doesn't work. Oh, there's another problem here. You can't even, in this particular case, right, unless you put in the test explicitly, you can't even guarantee that that month has a valid value, right? You can't even guarantee it's between 0 and 11 inclusive, right? If you wanted to, you'd have to put in an if statement here to check if the incoming month actually has the correct value. Right, so that's no good, right? You can do things like perform arithmetic with days and months, so you can write January plus February. Doesn't make any sense, but you can write it because they're both ints. And you can compare them now, right? So you can compare days to months or months to days. It might actually be useful to compare months to months because you might want to know whether one month comes after another. But you can compare any int to a month, for example, which doesn't make any sense, right? There's another problem as well, right? If you have the constant January, like, sorry, right? And you want the string corresponding to that month, there's no way to do it, right? You'd have to write a method where you pass in an integer value and convert that integer value to a string, right? So if I wanted to print the string January, notice that I actually have to write January in myself here rather than getting the name from the constant. It would be nice if we get the name from the constant, right? So there's no toString method for ints, so I can't easily convert a constant to an int. Sorry, a constant to a string. Right? So you can get rid of the old problem. Sorry, you can get rid of the last problem. So if I want to get a string from a constant, I can use string instead of int for my constants. Right? So this runs into all the same problems. Right? All of your enumerations are now strings, so there's still no type safety. Right? I can write a method that takes in a string that's supposed to be a day, but it will accept a string that's also a month. Right? It'll accept any old string. Right? You now also run into the problem that programmers are very lazy. So everybody now starts writing the string big S Sunday everywhere because you've got a constant, because that's what they know the constant is named as, right? Instead of using the actual constant name, which is probably something like month.Sunday, right? The name of the class that Sunday is defined in. Right? And that causes a problem because if you change the string from Sunday to something else, say big SUN, you now run into a problem. And comparing strings for equality is much slower than comparing ints or addresses, right? One of the advantages with using an int, right? It's very easy, it's very fast to compute whether or not an int is equal to Sunday, for example, right? You're just comparing is an int equal to 0. With strings, you have to compare, whoops, sorry, every character in the string to determine equality, right? And so that's much slower than just comparing plain old ints. All right, so we would like to get rid of both of these problems. In particular, we're really interested in type safety, right? If I have a method that accepts a month, it should only accept months. And so in version 5 of the language, notice it took them a while to add this feature. Java added its own enum type. Right? And so enums in Java, they're just classes, right? But they're special classes. So they are classes that are that inherit from this class big E enum. Right? When you create one of these classes, you don't have to say anything about this class. Because Java enumerations are actually classes, right, you can add fields and methods to your enumerated types, right? And that's something that you definitely can't do if you're just using a plain old int, right? So now, for example, you can now write a method that belongs to a month. And it gets even better, you can write a method for each month, right? So each month can have its own customized version of a method. And that turns out to be very powerful. Right? So enumerations are meant to represent a fixed number of constant values. So it doesn't make sense to have a constructor in an enumeration. However, they can, it's just that they have to be private. Right? And so we'll see why you might want to have a private constructor in an enumeration in a few minutes. So enumerations are dead simple to make. Right? It's, instead of the word class, you use the word enum, and then you just list your constants separated by commas. Right? So my constants are Sunday through Saturday. They're constants, so they're in all caps. Right? Each one of these constants corresponds to one day object. Right? So Sunday is a day object. Right? Monday is a day object. Tuesday is a day object, and so on and so on and so forth. Right? The language guarantees that there's exactly one object called Sunday. There's exactly one object called Monday, and so on and so on and so forth. Right? So there's no way for anybody, including the compiler itself, to make more than one Sunday object. Right? There's always exactly one. Right? Okay, so how do you use this thing? Well, it's just a constant, right? So you just write the name of the class, dot, and the name of the constant. Right? So day.Thursday is the day object that corresponds to Thursday. Right? You can print out that object, and you get the name of the constant. Right? So the enumerations have their own built-in toString method. Right? And you can change that method if you want to. Right? You just override toString. All right, so the language guarantees that exactly one object corresponds to each one of your constants, right? And that means you don't have to use equals if you don't want to, right? You can safely use equals, equals, or not equals to determine if an object is equal to a constant, right? There's no constructors or no non-private constructors, so nobody else can actually make another instance of one of your enumeration objects. There are also types, right? So it's just a class, right? Every class represents a type, and that means you get all the benefits of compile time safety, right? So for example, back here, right, we can write a little method that operates given a month, right? So public static int, something else. I guess just print a month, m. Right, so month is a public static void, sorry. Right, so our month enumeration, which is right here, looks a little bit different than the other one. I'm going to show you how we implement this in just a second. Right, but it has a bunch of constants, January, February, and so on. Right, so to print a month, I can just, well, print the month. Right, there's nothing for me to do. I can just do that. Now this method here only takes in month objects, right? It won't take in an int, it won't take in a string, right? It won't take in a day, it only takes in months, right? So I don't have to do any testing on whether or not m is a valid month object, right? It's guaranteed to be a valid month object. So that's nice, right? We've got compile time safety now. And so you can the part that's missing from this slide is that if you write a method that takes in a month, it only takes in months. Right? You even get comparable for free. So you can compare the constants in your enumeration. Right? The one disadvantage with this method is that you're stuck with the version of compare to that you get. Right? So remember the comparable interface says that compare to must exist. Right? The way that compare to exists for an enumeration is that the smallest object is the one that's listed first. Right? So Sunday is the smallest day, Monday is the second smallest day, Tuesday is the third smallest day, and so on and so on and so forth. right? And so the compare-to works by looking at the order that the constants were defined in, right? For the months, January is the smallest month, and so on and so on and so forth. So for example, if I have 3 days, right, D1, D2, and D3 that are Monday, Thursday, and Saturday, you can use compare-to compare them, right? Compare-to returns the number of positions that the two values differ in, right? So D1 compared to D2, so that's Monday compared to Thursday, right? Thursday is 3 days after Monday, or Monday is 3 days before Thursday, so we get -3. Right? Saturday compared to Monday, so Saturday is 5 days after Monday, so we get 5. Right? Thursday compared to itself, well, it's the same day, so we get 0. All right, so because enumerations are actually classes, you can put data into your enumeration. And this is something that you can't do in C, for example. Right? In C, you just got a plain old int. So if you have data or fields that belong to the individual enumeration objects, right, you still have to initialize those fields. So you do need a constructor of some kind. Right? Any constructor that you put into the class, though, is always private. So it doesn't let you make a constructor that's not private. So here is our month class, our month enumeration. So I want to store the number of days belonging to each month. Right? And so the way you do that is you create a field called days. Right? Now remember, enumerations are supposed to be constants, so it usually makes sense to make the fields final, although you don't have to. Right? Here I'm making it final just to emphasize the fact that the number of days doesn't change for each month, except for February, but we'll see that in a second. Right? You create a constructor, right, that takes in the number of days for each month. Right? And so you set your field to equal the number of days. Right? Can't put public here. If you put public, you get an error. You're allowed to put private or just leave it blank. It automatically becomes private. Right? So there's our constructor. Now, to actually make the individual objects, right, you have to call the constructor. So it's this sort of funny syntax here where you declare your constant and then you pass in your constructor arguments. Right? So January has 31 days, February has 28 days, and so on and so on and so forth. Right? You can add methods to your class, to your enumeration, because it's just a class. Right? So we can add in a method called days that returns the number of days for each month. Right? And we can even figure out the correct number of days for February if we ask the user to pass in a year. Right? So if they pass in a year, we check if it's a leap year or not. Right? If it's a leap year, we add 1 to the number of days, assuming the day is February. Right? So if the day is not February, you just return the value sitting in the field. Right? Otherwise, you add 1 to it if it's a leap year because it's February. Right? And away you go. Okay, you also get a bunch of other methods that the compiler generates for free. Right? So you get a static method called values. Right? So values returns an array of your constants. Right? So if you want to know what constants your enumeration has, just call values and you get an array of those constants. Right? So for example, using month, right? If we call values, the values method belonging to month, right? We can print out all of the months if we convert the array to a string. Right? And so here we can see that all of our, the name of all of our constants now appear on the output. Right? This is useful because if you know the name of a constant, you can convert the name to an actual object. Right? So I'll show you how to do that in just a second. So here's another example using month. Right? Month.values returns an array of the constants, so you can iterate over that array. Right? So for each month m in all of my constants, right, I can print out the month and the number of days belonging to that month in the year 2018, for example. Right? And that would print out the following. Right? If you know the name of a constant, you can actually generate the constant itself. Right? So given a string that corresponds to one of your constants, you can call the value of method, and that gives you back the enumeration constant corresponding to that string. Right? If that string doesn't correspond to one of your constants, you get an exception. right? So value of returns the constant that corresponds to the argument string, right? So for example, month value of May gives you back the object May, right? It gives you back the month object May, right? And so that's neat too, right? You can convert between a string. You can convert the constants to a string, and then you can convert the strings back to a constant. And that's super handy if, for example, you need to read stuff in from a file, right? And you need to initialize objects based on the contents of a file. Right? And the really crazy thing about the enumerations is that each one of your constants can have its own version of a method, right? And that's really unusual. So, so far we haven't seen an example of being able to do this, right? And this is really your first introduction to inheritance in Java. Right. Okay, so the way you do this is you declare what's called an abstract method in the enumeration class, right? So an abstract method is a method that has no implementation, right? So that's why it's called abstract, right? So that's what the word abstract means. So it defines a method, says what the method should do, right? Provides its signature and everything, but there's actually no body to the method. So it's similar to the methods in an interface. And in fact, all of the methods in an interface are abstract methods. Now, inside each constant, you implement your own version of that method. Right? So for example, imagine you had an enumeration that represents the operations on a calculator, right? So addition, subtraction, division, and multiplication. Right? So your calculator supports a finite number of operations, right? So here we're going to implement 4, right? So there's the plus operation, there's the minus, times, and divide, right? Addition, subtraction, multiplication, and division, right? Our enumeration says that there is an abstract method called apply, right? Apply simply takes x and y and applies the operation to x and y, returning the value, right? So x plus y, x minus y, x times y, x divide y. Right? Each one of your constants now provides its own implementation of apply, right? So plus provides an apply method that simply returns x plus y, right? Minus provides its own operation that returns x minus y. Right? X times y and x divided by y. Right? So you now customize a method for every object belonging to the enumeration. Right? And that too is also very powerful. Okay, so when should you actually use these enumeration? When should you actually use an enum? Right? And so the place, when you should use an enum is when you have one or more constants, right? And you know that you're never, or probably never, going to change those constants or add to them, right? Or take some away, right? And so these things are super useful in a lot of programs that need to take in some sort of configuration information, right? So for example, there's a lot of cases where you want to write a method or a constructor and it takes in a Boolean value of some kind, right? True or false. So if you're implementing a class that represents binary digits, right, zeros and ones, you might provide a method or a constructor that takes in the value as a Boolean value, right, as a true or false value. Presumably, true corresponds to 1 and false corresponds to 0. But you don't actually know that unless you look at the documentation for the constructor, right? Similarly, you might have a class for a thermometer that uses a temperature scale that's either in Celsius or Fahrenheit. Right? Presumably true means degrees Celsius, false means degrees Fahrenheit. Right? If you just look at those constructors, right, it's not immediately clear what are those constructors doing, right? But if you use an enumeration, right, you can now make it absolutely clear what are these constructors doing, right? So you can make a enumeration called binary value, and it has exactly 2 values, right, 1 and 0, right? Now I can make a binary digit whose value is 1 or 0, right? I don't have to interpret what true and false actually mean. Right? For my thermometer, I can make an enumeration called temperature scale that is either Celsius or Fahrenheit, right? And now it's dead obvious what's happening here, right? So enumerations can make your program a lot easier to read, right? If you're in a situation where you're trying to implement a class and you happen to know that the objects of that class really are a set of constants, and you know the number of them, then you can go ahead and use an enumeration. Right? So there's a card class that's in the, I guess it's here, so let's look at it. There's a card class that's, if I can find it, in the course notes. Right? So the card class represents a playing card. Right? So it's got a value and a suit, right? A rank and a suit. So the implementation that's here in the basics package uses a string to represent the rank and a string to represent the suit. Right? Now the problem with this class is if you want to make a card, right, you're going to pass in the rank and suit for the card. You have to test, is the incoming rank actually a valid rank, and is the incoming suit actually a valid suit? Right? And so there's all of these testing conditions here. Right? So does that list of ranks actually contain that rank that just came in, that was just passed in by the caller? Right? If it isn't, throw an exception because I can't make a card with that rank. Right? Is the incoming suit valid? Right? If not, throw an exception because I can't make a card with that suit. Right? If instead of using a string for the rank and a string for the suit, right? So instead if you use an enumeration, hopefully I have this. I don't, sorry, it's not here, right? If you use an enumeration for the rank and an enumeration for the suit, right? So your ranks, you have 4 ranks. Your suits, you have 13 suits, I think. You don't have to do any of this validation at all, right? That becomes type rank, that becomes type big S suit, right? And you never have to worry if the incoming rank or suit is valid or not, right? You've already defined the valid ranks and suits. Right? So it becomes much easier to implement this class if you actually use enumerations. Right? So enumerations are useful. They don't show up in every program because you don't always have a situation where you have a fixed number of constants, right? But when you do, they become very useful. Right? They make your program a lot easier to read. They make it a lot easier to use. All right, so that's enumerations in Java. And so that ends part 1 of the course. Right? So part 1 of the course is basically introduction to the language and introduction to objects. Part 2 of the course now describes what happens when you have multiple objects and the relationships between them. Right. Okay, so we were already seeing UML class diagrams, so the first few slides are repeated from a previous lecture. Right. So I want to jump right into the relationship between classes part. So a typical object-oriented program is made up of multiple interacting classes. Right? It's very unusual to have a program that only has one class. Right? And so especially when you have a large program that has many different types of interacting objects, the relationships between those classes becomes important so that you can understand how is this program working. Right? So for example, you might have classes that are built using other classes. Right? So that describes the structure of classes. And you might have classes that interact with other classes. Right? Well, you always have classes that interact with other classes. So that describes the behavior between classes. Right? There are different UML diagrams that describe behavior and describe structure. We don't look at the behavior diagrams in this course. Okay, so we're interested in the structure in this course, right? So how do you make a class that uses other classes? Right? And so you need to talk about the relationship between classes, right? And so the weakest relationship you can have between classes is called dependency, right? So dependency just means that a class uses another class. Right? That's all that it means, right? And so this models the uses relationship. Right? So we say that if a class X uses another class Y, then X depends on Y. There's supposed to be a Y here. Right? Now, it can also be the case that Y depends on X. Right? So you can have a two-way dependency relationship. How do you know if X depends on Y? Well, you just look at the class X and see if Y appears anywhere. Right? So if Y is a field of X, then X depends on Y. Right? If you've got a method that mentions Y, method or constructor that mentions y, then x depends on y. Right? So if you go and look at the class object, right, the class big O object, right, and you just scroll through its documentation, right, you see that there's a toString method that mentions the string class. Right? So we know that object depends on string. Right? We also know that it depends on this class called big C class. Right? And that appears to be all of the dependencies that object has. Right? So even the class object, which sits at the top of Java's inheritance hierarchy, depends on other classes in the language. Right? If you look at the string class, right, and scroll through, bloop, 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 you don't even have to scroll through. If you look at the top, right, you can see right away that the string class needs the object class. Right? So string depends on object. Right? If you scroll through and look at the, yeah?
Do all child classes depend on the parent class?
Yes. Yeah. So the relationship between child classes and parent classes is dependency, but it's also stronger than dependency. So we'll look at that in a little bit. And you can see that there's a bunch of other classes that string depends on, right? So it depends on this thing called charset, string buffer, string builder, right? And it also depends on somewhere, object there, right? So it also depends on object because object appears as an argument in the equals method. Right? So for the string and object classes, they have a two-way relationship, right? They depend on each other. So you can show that relationship with a UML class diagram. Right? And so our point2 class depends on the class string. Right? So it has a toString method. Right? So it depends on the class string. So the way you show dependency is you write the two classes as a box, right? And then you connect them using a dashed open-ended arrow. So believe it or not, all of the actual, like that dashed, the fact that this is dashed is important in UML. The fact that that's an open arrow is important in UML. Right? Point2 also depends on this class called vector2, which we haven't talked about in the course. But it also depends on vector2. So you can show that relationship by drawing a dashed line with an open arrow. Right? Vector2 depends on string because vector2 has a toString method. Yeah?
If there's another dependency of vector2 that point2 didn't depend on,
yeah,
would that still count as a point2 dependence, or do you not?
No. So you don't model, so we're only interested in the direct dependencies. Yeah, but that's a good question. All right, so dependency can also be two-way. So for example, you might go into the vector2 class and modify it somehow so that it also depends on point2, right? So for example, you might have a constructor in vector2 that takes in 2 points, right? You compute the vector by subtracting the 2 points. Right? If you had such a constructor, vector2 would then depend on point2. Right? So this relationship here can be two-way, right? And you indicate that with 2 separate lines with arrows pointing in the opposite directions. Okay, so that's dependency. So dependency is pretty straightforward, right? If a class uses another class, there's a dependency relationship. Association is a stronger form of dependency. Right? So association models HASA. Right? And so HASA means that your class X has a field of type Y. Right? So when you look at the fields, if any of those fields are of reference type, you have an association relationship. Right? And like dependency, association can be two-way. Right? So if X has an association relationship to Y, Y can have an association relationship to X. Sorry, this is from another class and from a previous year. So there's, in a previous version of this course, there was this class called ranged value and there was a class called range. Right? So range is just a mathematical interval, right? So between, say, 0 and 10. A ranged value is a value somewhere in that range. Right? So every ranged value object has its own internal range object. And so you can model that as an association relationship. Right? An association relationship is shown with a solid line, no arrows. Right? If you want to, you can include the multiplicity. So what this diagram is saying is that every ranged object has one has one field whose type is range. Right? This is an example from a from the standard UML textbook that shows the relationship between a class called show and a class called performer, right? And so this is supposed to be modeling like a Broadway show or something like that, right? There are some names on the diagram. So there's this name orchestra, there's this name cast, there's this name backup, right? So orchestra is the role between, that describes the relationship between a show and a performer, right? So to read this diagram, what this says is that if you look at the line from show going to performer, right? So a show can have any number of performers, right? A performer might belong to any number of shows, as a member of the orchestra, right? So a show might have any number of performers who are in the orchestra. A performer might be a member of the orchestra in any number of shows, right? And similarly, the same is true for cast, right? So a show might have any number of performers who are part of the cast, right? And a performer, might be a cast member in any number of shows, right? And then there's this relationship between between performers, right, in the backup role, right? And so this one's tricky to read. So a performer might be a backup to either 0 or 1 lead actors, is the way you read that. Right. So that's association, right? So association just means that a class has a field that happens to be a reference type. And now we talk about aggregation and composition. Right? So as we're going, the relationships get stronger and stronger and stronger. Right? So aggregation and composition are just stronger forms of association. Right? The term aggregation is controversial. So not everybody believes this is a proper relationship. Right? Okay, so both terms describe HAZA. Right? So remember that I just said that association is also the HAZA relationship. Right? So you know that if something is an aggregation or a composition, right, it has fields that are of reference type. Right? So for example, a university might have a collection of departments. Right? Every department might have a collection of professors. Right? So we're still HAZA. Right, so at this point, we still don't know if this is association, aggregation, or composition. Well, we know it's association. We don't know if it's a stronger relationship yet. Right? So composition implies ownership. Right? So for example, if the university disappears, right, so if Queen's University were to go away for whatever reason, all of its departments also go away. Right? You can't have a department that exists without the university. So a university is a composition of departments. Right? Aggregation does not imply sole ownership. Right? So if a department disappears, so for example, suppose for whatever reason, we decided to get rid of the School of Computing Science, right? It's not necessarily the case that the professors also disappear. Right? In fact, it's almost certainly the case that the professors just go to other departments. Right? So a professor can exist without the department. Right? A department cannot exist without the university. Right? Professors can exist without a department. Right? And so the department is an aggregation of professors. Right? Now, aggregation and composition, the way they differ from association is that they are one-way relationships. Right? So association, you can have a two-way relationship. In aggregation and composition, the relationship is strictly one way, right? So something is made up of something else, right? But the opposite, it can't also be true, right? So X can be made up of Y, but Y cannot also be made up of X, right? So if you see aggregation or composition, you can just think made of, right? Or made up of. So imagine that a person has a name and a date of birth, right? You often see the person example in these introductory programming courses. It's not a great example, but it shows up a lot, right? So a person has a name, they have a date of birth, right? So if we look at the code and we look at the constructor, right? You see here that the field name just gets set to the incoming name, right? And the field birth date just gets set to the incoming birth date, right? Notice There's no new string object created here. There's no new date object created here. Right? When you return the name, right, you don't return a new string object. You just return a reference, whatever your field is. Right? And when you return your birth date, you don't make a new date object. You just return your birth date. Right? So that example there is using aggregation. Right? So for example, if I was to ask you to implement the person class and provide a constructor and a get name and a get birth date method, at this point in the course, that's the code you would probably write. Right? These fields are of reference type, but you're treating them like they are primitive values. Right? This name equals name, this birth date equals birth date. Right? Return this name, return this birth date. So no new objects are being created. Right? So notice that that constructor doesn't make a new copy of the name and birth date objects that it was passed. Right? So it's not making a new copy, right? That means it doesn't own. Right? Whatever name this thing, whatever string this thing is pointing to, and whatever birth date this thing is pointing to, the person object doesn't actually own that object. Right? Somebody else has a reference to that object. Someone else has a reference to that object. Right? And so the person object can't possibly own the name or date object. The string or date objects corresponding to the name and birth date. Right? So the name and birth date objects, they're being shared by whoever called that constructor. Right? So both the caller and the person object are holding references to the same objects. Right? So for example, the caller makes a string and they make a date. Date's weird. So that's the date 1991 March is the month number 2, and that's the 26th day. Right? This is an actual class in the Java standard library. Right? If someone makes a person object using that string and that date, this is the following picture in memory. Right? So the caller has a string and a date object. Right? So that string is just that string object there. Right? That date object is just that date object there. The person object, it has a field called name, but that field just points to that string object there, right? So caller has a reference to that string object. The person object has a reference to that string object. No one actually owns that object, right? It's shared ownership here, right? Similarly with the date, right? That date, points to that object there. That date points to that object there. No one actually owns the date. So this is aggregation. Right? It's aggregation because, right? Because a string does not have a reference to a person and a date does not have a reference to a person. Right? The relationship here is strictly one way. Right? Person has a reference to a string, person has a reference to a date. String does not have a reference to a person, date does not have a reference to a person. Relationship is strictly one way. Right? So this is aggregation. Okay, so in aggregation, right, no one owns that date object. So if that date object was to change for some reason, both whoever has a reference to that date object will see the change. That means the person's birth date can change. Right? So for example, the caller has a name, Billy Bob. They have a date, March 26, 1990. Then they make a person object using that string and date. If the caller changes the date object, changes the state of the date object, right? So they now change the date to November 3rd, 1995, right? If you ask the person what is their birth date, it's now November 3rd, 1995, right? So the person object doesn't control its own birth date, right? Somebody else can change the birth date of the object without asking the person object itself. Which might be strange, which you might think is strange, but that's simply the consequence of using aggregation. Right? So because that date instance is shared by the caller and the person object, right, the caller can modify the date, right, and the person object now sees a changed birth date. Similarly, the person object can change the birth date, and now the caller sees a modified date. Right? So nobody actually owns the birth date object. Now notice the string object, the name, right? That's being shared by both the person and the caller, right? But neither the caller nor the person object can actually modify the string, right? Because the string's immutable, right? So immutable objects make very good building blocks for other objects, right? Because their state never changes, you don't really care about ownership anymore, right? You can freely share that object, no one can change it, so you never have to worry that its state has changed on you, right? And so that's one of the big benefits of using immutable objects, right? It makes your code much easier to write, it makes it much easier to maintain, and it makes it much easier to debug. But they're not always feasible to use, right? Often you want an object whose state can change, right? So to show an aggregation relationship, the picture looks slightly different than association, right? It's still a solid line, right? But now the whole object, so person is the aggregation, right? It gets diamonds attached to it, right? So open diamond on the person object and a solid line connected to date says that person is an aggregation of one date object, right? And person is an aggregation of one string object. Right? So the diamond goes on the whole object, right? No diamonds go on the quote-unquote part objects, right? The objects that the whole is made up of. All right. I guess that's a good place to stop. And so the next lecture I'll tell you about composition, and composition greatly complicates your life. So you have to be careful to make sure that you do a whole bunch of things when you're implementing a composition.